Permutations and combinations. Permutation is every possible order of objectives. Alright, you need to know the definition of permutation. It's every order that is possible. Okay? So, write this down. It says a travel agency is planning a vacation package in which travelers will visit 5 different cities around Europe. How many ways can the agency arrange the 5 cities along the tour? So, alright, so let's say your first stop. How many cities can you pick from? 5. On your second stop, how many cities do you have to pick from? 4. Okay? Because you've already visited one city, haven't you? Okay? On your third city, how many do you have left? 3. Okay? Now what we do to find this permutation, okay? We just take 5 times 4 times 3 times 2 times 1. Just multiply all the possible combinations. 5 times 4 is 20, right? 3 and 2 is 6, right? 1, it doesn't matter. You can leave it off, okay? 6 times 20 is 120 different ways. Okay? 120 different ways. All right, you need to write this down. This is what we call a factorial, okay? Permutations, okay? They use factorials, all right? A factorial is just a number with a exclamation point behind it, okay? Or no, it's behind it.
Why is the exclamation point?
It's factorial is just they use the exclamation point.
Is it supposed
Okay?
to mean something?
Yes.
What's it mean?
So in factorial here, okay, when you say exclamation point, you say factorial, okay? So in factorial just means n times n minus 1 times n minus 2 times n minus 3 all the way down to where it's 1. 1's the only thing left. Dots mean continue on, right? Okay? Like here we did 5 factorial. You didn't even know it, but we did 5 factorial, okay? On the last one, we did 5 times what? 4, which is 5 minus 1, right? Okay, times 5 minus 2, which was 3, times 5 minus 3, which was 2, times 5 minus 4, which we get 1. That was what we did on the problem before. We just didn't write it with a factorial sign.
I thought the written equation was easy. Yeah.
Okay? So, this is what we use. We use factorials. Okay? Now, we have a permutation formula. Okay? Where the permutation of a number, okay? The n would be your number of objects. R is how many objects are taken. Okay? Because this is like if you don't use all the cities. Okay? In the problem before, we used all the cities. We have 5 to pick from. We visited all 5. The permutation formula is when you have 5 cities to pick from, you only use 3 of those cities. Alright? What you do n factorial, so the number of objects factorial, over n minus r factorial. Okay? And we're going to do a problem like that here in just a second. Okay, you need to write this down, all of it. Okay? Alright, this is a librarian is placing 6 out of 10 magazines on a shelf. How many ways can she arrange the magazines in the case? Alright. So, here's what we're going to do. Okay, we're going to do a permutation, okay, with 10 is our number, right? 10 is n. 6 is going to be our r, okay, because that's how many objects is being taken, all right? N is, your r is how many objects are being taken. 10 is the total number of objects, okay? If you remember, the permutation formula is n factorial over n minus r factorial, okay? Which we're saying n is 10, so we need to do 10 factorial over 10 minus 6 factorial. Okay? 10 factorial, and just 10 times the number that's less than that, times 8, times 7, times 6, times 5, times 4, times 3, times 2, times 1. Okay, factorial is just when you multiply all the numbers starting with the first number, okay, in consecutive order. All right, that's why we did factorial just a second ago. Okay, Now, we're going to put it over, what is 10 minus 6? 4. So we're going to do 4 factorial, which is just 4 times 3 times 2 times 1. That's what we're going to divide by. All right? Any questions on how I got to this point?
Yeah. Well, you got 2, 2.
Oh, it should be 1, sorry.
Well, that would be negative.
There's no negatives, no.
Never.
How can you have a negative when we're talking about magazines? Yeah, exactly. All right, now, before I add all this up and do all the division, I can cancel something out. 4s will cancel each other out. 3s, 2s, and 1s, right? The 1s you really don't even have to write. But. Okay, now what we do is we just take 10 times 9 times 8 times 7 times 6 times 5, which you get 151,200. Okay, that's how many ways she can put 6 out of 10 magazines on a shelf. Okay?
She ain't gonna do all that. Unless she like.
Alright, now we did permutations, we're going to do combinations, where the selection of objects in which order is not important. Okay? Combinations is when order is not important. Permutation order was important, right? When we were trying to pick the cities, right? The order mattered. Here, the order does not matter, so we get a different formula. We get C times N, comma R. Okay, N is still the number of objects. R is still the number of objects being taken. Okay. The only thing that is different is you take N minus R factorial times R factorial. Okay. So your number is going to be smaller. Okay. Because order doesn't matter. Okay. When order matters, you have a bigger number of options, right? Okay. Here the order doesn't matter. Okay. Everyone have this formula written. Alright, what you need to do is write this down. Alright, this says Mark has been asked to display 5 different styles of shirts from the wall of this store that has 8 shirts on it to put on display. Okay? So he's got to pick 5 shirts, 5 different styles, and he gets 8 shirts to put on the wall. Okay? Alright, so how many ways can Mark choose the shirts? Okay? Does order matter here? Okay? No, it doesn't.
Wait, what do they mean by order?
Okay? Doesn't matter which shirt he puts on the wall, like which order that he puts the shirts on the wall. No. Like the Hawaiian style first, and then the polo second. Does that matter? No. Does it say it matters? No. Okay? Before when it was permutation, the order mattered, like cities, right? Does it matter which order you go in? Yeah. Okay, here it doesn't matter. Okay, so this is what we call a combination. Okay, it's a combination, okay, of 8's our number, right? 8's the total thing we can pick on, and then R is the number we get the objects are taken from, right? We have 8 total shirts to pick from. 5 of them are going on the wall, so 5 is R. Okay, everybody with me? Okay. Now we're supposed to use our formula. I'm going to write down the formula for combination. It was N factorial, okay, over N minus R factorial times R factorial. That's the difference. Okay, it's going to be a smaller number than if you were doing permutation, where order mattered. Okay, N factorial. So we're going to do 8 factorial. Okay, over 8 minus 5 is 3 factorial. And then times it by 5 factorial. Okay? So, 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Right? Okay? 3 factorial is 3 times 2 times 1. 5 factorial is 5 times 4 times 3 times 2 times 1. Alright? Everybody with me? Okay, so we cancel out the 4, the 5s, the 3s, the 2s, the 1s. Right? So you get 8 times 7 times 6 divided by 3 times 2 times 1. So 8 times 7 times 6 is 336. Okay. 3 times 2 is 6. So, okay, 336 divided by 6 is 56. Okay. There's 56 ways he can put the shirts up there. Okay. Any questions? All right. Now, sometimes they won't give you a situation, a scenario. Instead, they'll just give you C or P with the symbols. Okay.
Combination.
This is a combination of 18 total objects. All right. You're only taking 4 objects. All right. No. Okay, I would rather do this. Okay, this is like what Shane wants. He wants less information.
Yes.
Okay, so this is going to be 18 factorial over 18 minus 4 factorial, so 14 factorial times 4 factorial, right? Because n minus r times r. All right, everybody with me? Okay, so let's do 18 factorial. Shane, please be quiet. I think I know what comes after 18. Try to squeeze in here. That's a 3. We got 2 times 1. All right. Now, 14 factorial. Shane, be quiet. All right, and then 4 factorial, so 4 times 3 times 2 times 1. Okay, so 14 through 1 is canceled out, all right? We're left with 18 times 17 times 6, 15.
Why don't you just don't do that in the first place?
Yeah, well, because we already knew that, so once you just write 18
Nope.
through 15.
Okay, 18 times 17 times 16 to 15 is 73440. Over 4 times 3 times 2 times 1 is 24. So 73,440 divided by 24 is 3,060. That's how many options there. I don't know, it doesn't matter, does it? Say you got 18 different C's to pick from. It doesn't matter which order you go in, you got 4. You just get to go 4. Okay.
There's 4 to choose. Good choice.
All right.